Hello there. Today we want to take some problems on motion of connected bodies, which is a topic in further mathematics SS2 class. The first question. A light non-stretchable string passes over a smooth pulley and carries masses of 4 kg and 3 kg at its ends. The masses are released from rest. A. Find the acceleration of each mass. Let me quickly say here that these masses, these bodies move with the same acceleration. Since this weight is greater, then the heavier mass of 4 kg accelerates downwards and the other upwards. So what we need to quickly do here to find the acceleration and tension in the string is to analyze each resultant or net force and then use the equations of motion, precisely the second law. Now, we need to generate equations of motion which have been given in this solution, but let me quickly explain how I arrived at these first and second equations. Now, the resultant or net force for this first body is 4g minus t, since this body accelerates downwards. So that is what we have here, and that equals 4a from second law of motion. Likewise, for the second block, the resultant force here should be t minus 3g, which is what we have here, since this body accelerates upwards, and that also equals 3a, also from second law of motion. Now, solving these two equations simultaneously by elimination method, then we should have our g to be equal to 7a, and that makes the acceleration 1.4 meters per second square. Now to question B, which is to find the tension in the string. Now, all we quickly need to do here is to put our A we found initially to be 1.4 into any of the two equations. I prefer the second equation, which is T minus 3G equals to 3A. So when I put A into the equation and my G into the equation, I have my T to be approximately equal to 34 newtons. Now to question C, which is what is the reaction at the axle of the pulley? Now, the diagram for the solution is presented here. Now, our masses are not parts of this pulley, so we only consider, since we are asked to find the reaction at the axle of the pulley, we only consider this pulley, including the string suspending the two masses. And since this pulley does not have acceleration vertically, this pulley is not moving vertically, it means that our vertical forces are equal. That is, the normal reaction here should be equal to the sum of these two, and that is why we have our T to be equal to 2, our R to be 2T, and that makes R to be 68 newton.